Dear students, today we are going to discuss few more questions of this exercise 8.1. Now the question number 7 of this is find the area of the smaller part of the circle x square plus y square equals to a square cut off by the line x equals to a by root 2. So this means that here the line is vertical line that is perpendicular to x axis. Now given circle is x square plus y square equals to a square. This means that this circle has center 0 0 and the radius is simply a. So this means that if we consider the point on this, that is point a, then its coordinates are a0 because radius is here a. Also this a by root 2 is always less than a, which implies that this a by root 2 point lies within this circle that is here, point B. Now if we draw a line perpendicular to this axis from this point through this point, then this is the required line, this x equals to a by root 2. So this means that this line cuts or intersects this circle at 2 points, that is C and D. So this means that we get two parts, smaller part and the bigger part. Now we have to find the area of this very part, this very portion, because it is the smaller portion. Now here it is symmetric around this x-axis because it is circle and this x-axis is actually the radius of this circle. So this means that any point on this arc AC is of the form of x square plus y square equals to a square. That is, if xy is the point on this arc AC, that is on the arc AC, then it satisfies x square plus y square equals to a square, because this x square plus y square a square is the equation of circle, and this part AC is actually the part of this circle. That is why the points on AC satisfies this equation, which implies that from this we can simply say that this y equals to root a square minus x square. Now here value of the x is a by root 2 and the another value is a. So if we consider the right, this vertical strip, that is with y dx, its area is y dx, then the area of this portion a b c a, that is this very portion in the first quadrant, is, we have to integrate y from a by root 2 to a, that is root a square minus x square from a by root 2 to a. Now this is second order integral, its value is x by 2 root a square minus x square plus a square by 2 sine inverse x by a from limits a by root 2 to a. Now substituting these values, we simply get a square by 4 pi by 2 minus 1, that is a square by 4 pi by 2 minus 1. Now we have to find the area of the smaller portion, and this smaller portion is this very portion, AC AB ADCA. Now required area is simply here twice the area of ABCA, that is twice the area of this, which is a square by 2 into pi by 2 minus 1 square units. So this is the required area of this smaller part of this circle cut by line y x equals to a by root 2. Now another question is, which is question 9, find the area bounded by y equals to x square and y equals to mod x. Now you know that both the one curve y equals to x square, which is parabola, upwarded parabola, and it is symmetric about y axis. Similarly y equals to mod x, it has graph v-shaped graph. This means that this too is symmetric about y axis. Now when we draw the graph of these two functions, that is y equals to x square and y equals to mod x, these two graphs intersect each other at 3 points, at A, at O, and at B. Now we have to find this area, this is shaded area. Now how to find the point of intersection between these two curves? By substituting y from these two equations, that is when y is mod x, substituting given y equals to x square, which implies that mod x is x square. Now this is only possible, x square is positive, mod is positive, and both are equal. This is only possible when x is 0, x is 1, and x is minus 1. So this means that when x is 0, y becomes 0 0, that is this point center, this origin. Now when x is minus 1, when x is minus 1, here y becomes positive 1 because y is mod x square. That is when x is minus 1 square is simply 1, or y is mod x when x is minus 1, mod of minus 1 is 1, which implies that here coordinates of a are minus 1 1. Similarly for b, when x is 1, y is 1. So these are the 3 points. Now we have to find the area of this. Clearly this mod x, that is v-shaped graph, lies above this curve, lies above the curve of y equals to x square. So this means that here we have minus 1, x is minus 1, here x is 1. Firstly we will find the area from this 0 to 1, that is this very portion. Now it is from 0 to 1. Now area under this mod x minus area under y equals to x square. So this is the required area of this, because that is area under area of B of A, that is this shaded portion in the first quadrant. It is area under y equals to mod x from 0 to 1 minus area under y equals to x square from 0 to 1. Now in 0 to 1 mod x is always x, that is mod x can be replaced by x, which implies that integral 0 to 1 x and integral 0 to 1 x square, which is after simplifying 1 by 6. This means that area of this very portion is 1 by 6. But both curves are symmetric around y-axis, which implies that in particular their intersection is also symmetric around y-axis, which implies that area of this shaded portion in first quadrant equals to the area of the this portion in the second quadrant. Hence required area is twice the area of the first quadrant, that is OBBO, that is 2 into 1 by 6, which is 1 by 3. So this is the required area. So in this way we completed this very exercise. Inshallah in tomorrow's video lecture we will discuss another topic. So thank you.